get going, and we're up to case 8. So let's look at case 8. And I was using Roman numerals yesterday in class. Had technical difficulties, so I'll try and go back if I can. But anyway, case 1 through 7 we've already been through. But case 8, we've got the antiderivative of secant to the nth power with respect to x, or we've got the antiderivative of cosecant to the nth power with respect to x, where n is a positive odd integer. So n is odd, and it's also an element of the positive integers, which of course positive integers are also known as what? Whole numbers or natural numbers? Natural numbers. Positive integers are natural numbers. So we just have n as an odd natural number is another way you could say this. So basically what we're going to do is we're going to pull out a secant squared x for the first one, or a cosecant squared x, and use integration by parts. So we're going to use integration by parts. And when we do that, we're going to let u be, so we're going to let u equal what's left, secant to the n minus 2 power, all right, of x, or cosecant of n minus 2 of power with respect to x, and dv is going to be what you pulled out, dx. So secant squared dx, secant squared x dx, don't forget dx's, or cosecant squared x dx. So whatever you pull out, that's what dv is attached with the dx. So let's just look at an example of this. See if we can do one. Let's do, well, that's funny stuff. Let me erase that. So if I let take the antiderivative of secant, I don't care, you want to do secant cubed. Let's start out kind of easy since this is my first one of the day. Secant cubed dx. Basically, what I want to do is I want to rewrite this, and I want to pull out a secant squared. And since I'm going to let that be dv, I'm going to put it at the end. So what's left is secant to the 3 minus 2, anyway, so that's secant to the first x, secant squared x dx. And once again, I'm going to use different colors here, but this is what I'm going to let be dv, and this one I'm going to let be u. So integration by parts, let u equal secant x, and dv equals secant squared x, because that's what I pulled out, dx. Then the derivative of what is secant squared? So if I want to figure out the red here part, what's the derivative or antiderivative? The derivative of what is secant squared? In other words, the antiderivative of secant squared is what? Tangent. So that's why we're doing that. So v is tangent x. Of course, we're going to end up with a plus c. Remember, we worry about that at the end with integration by parts, right? So, and of course, on the green one, I had u here is secant x. So what's du? Secant x dx, right? Secant derivative of secant is secant tangent, right? Secant x tangent x, and then dx, right? All right. So basically, what does our problem become? So it's uv, so it's secant x tangent x minus the antiderivative of v du. So v is tangent x, and du is secant x tangent x dx. Okay. So now what? Derivative of secant is secant tangent, right? So how am I doing this one? This becomes minus the antiderivative of secant x tangent squared x dx, right? How are we going to do this one? Is that case number 7? It's case 7 now. We got to use case 7 to do. No, that's positive odd integer. So it's even. What case is this? Case 6, right? Case 6, we got tangent to the nth power of x, secant to the nth power of x, taking an antiderivative of that, where, no, that ain't it either, because that's where the second one's even. Which one is this? I don't see either one of you guys. Huh. So how are we going to do this one? Maybe. What's case 9 say? Yeah, it's the next one. No wonder I couldn't find it. So the integral of, we want to rewrite this one. That's what we want to do. So see this tangent squared? Is that the one we want to rewrite? So we want to rewrite that as secant squared x minus 1, right? So let's do that. So this is going to be minus the integral. I'm going to do it here first. Secant x times secant squared x minus 1 dx. Okay, and then if I multiply that out, is going to be, this is secant cubed x minus secant x, right? And I'm going to subtract the antiderivative of that whole thing, dx. All right, so let me try and remember this here. So it's secant x tangent x was what I had originally, right? And then minus the antiderivative of secant cubed, is that right? And so minus a minus though, so that'd be plus. So I'm subtracting the whole thing because I'm going to split it up. Okay, so we have, I believe, does that look right? Okay, so then we got to go, now we're back to case A. What was my original? My original was integral of secant cubed. Okay, what did you, so this is what the integral of secant cubed was. And I have one here. So what could I do to both sides? Add secant cubed to both sides. So that implies that 2 times the antiderivative of secant cubed x dx equals secant x tangent x plus the antiderivative of secant x. Now the derivative of what is secant? We don't have that one. Was that one that was in a back flap? Was that a natural log or something? All right, just a second. So secant x tangent x plus natural log of the absolute value of what? Plus tangent x? Secant x plus tangent x. Okay, and then of course I've got 2 of these equals that. So anyway, this is going to be 1/2 each part, right? And then plus c, of course, at the end. So this should be our final answer there for that. So biggest thing when you have a lot of different cases, we're trying to look for things that will help us out. And what time do we go till today? 53. So we don't have a lot of time. So what I'm going to do is I'm going to save 7.3 for tomorrow, because you really, there's a lot of different stuff in here with chapter 7. So just making sure that you can follow through and do one of each kind, those types of things. Let's see. Which I will, yeah, I'll try and record tomorrow. So, but anyway, that was case 8, and we had to use case 9. So we had to use case 9 in there, and I'll just real quick write up what case 9 is. And of course, Roman numerals, you can never have more than three in a row, so you can't put V I. You can't do that. So it's IX. So they use a subtractive property when you'd have more than 3 in a row. So IX is case 9 if I've got the antiderivative of tangent to the nth, x secant to the nth, x dx, where n is an even natural number, and m is an odd integer, positive integer, so an odd natural number. Okay, then what are we going to do? We're going to rewrite this if since n is even, we can rewrite, like tangent squared x is tangent squared plus 1 is secant squared, so it's secant squared x minus 1. And so what we can do is we can rewrite that, split that power up, divide it by 2. So I can rewrite this as the integral of 1, or secant squared x minus 1 to the n divided by 2 power, right? Because tangent squared to the n divided by 2 is tangent to the n power. Anyway, times secant to the nth power of x, and then with respect to x, and then multiply this out to that power, and then use the distributive law to multiply secant to the nth power times all that, and then use the other rules. And of course, we also have case 9 doing a similar deal. Fact, taking it out of cotangent squared. So if this is, let me just real quick do this. If this is cosecant, or excuse me, cotangent to the nth power and cosecant to the nth power, where we've got the same things here, then we would use the rule that cotangent squared is of x is 1, or excuse me, cosecant squared x minus 1. Okay, so that's the other trig identity we use, and we'd put that in here, etc., and do the same process. So I'm not going to do an example like that, since we kind of had to do that already. I do want to finish the day up looking at something back in case 1, which is 1 or 2. Let me see. When we had like antiderivative of sine to the 5th power of x, we have the book method to do it. So the question would, so if I have the antiderivative, I'm going to make sure this isn't an odd. It's not. If I got the antiderivative of sine to the 5th power of x with respect to x, what's our trick there? That was either case 1 or 2. Case 1. So case 1, we're going to pull out a sine x, and of course, if it's this is odd, n is odd. So if I have sine to an odd power, or if I have the antiderivative of cosine to an odd power, we're going to pull out a sine, or we're going to pull out a cosine. Okay, and then we're going to use the identity. So the way we did this is we rewrote this as the antiderivative of sine to the 4th So in this case, when I pull out a sine x, I'm gonna put it with the dx so that this is together here. And then what I want to use is I want to use the identity on the other part. So on this, I want to use the identity. And the identity, this is sine squared x quantity squared, right? And so what I could do is rewrite that as 1 minus cosine squared x quantity squared, right? And then if I multiply that out, FOIL that out, right, it's 1 minus 2 cosine squared x plus cosine to the fourth x. And then I'm going to take all of that times sine x, right, dx, and take the antiderivative of that. So really what I can do is I can multiply that sine x through there. And then, of course, I can just take the antiderivative of sine, right? So the derivative of cosine is minus the sine. So this would be minus cosine x for the first one. These next two antiderivatives, I can use substitution. I can let u equal cosine x, and then du is derivative of cosine is minus the sine, so minus sine x, right? And it flips the signs from negative to positive and positive to negative, but I can use substitution to solve those last two. And we did one like that in class, right? Remember that? So I'm just gonna say, all right, so that's great in theory, but we had to multiply this out. And I had on the board the other day, Luke saw it, I had on the board, like, if this would have been to the, instead of squared, if that was to the, what I have it, to the fifth power, or something like that, then we have a big long thing and it gets a little ugly, a little awkward. So you don't have to get very big. And that was just when we had sine to the 10th power left, right? We had sine to the 10th. But my question is, what if I made this, thing sine to the 101st power or something like that? How fun do you think it would be? That'd be a 50th power there. How fun do you think it would be to multiply that out? And the question is, well, this stuff is great only in simple exercises. So Professor Tim has an alternate method for big N. For case 1, alternate Tim's method for case 1. And so I'm going to finish the day, hopefully, by doing that. If we had something really big, this is for big N on case 1. So let's just look at that. I'm going to need some space here, though. All right. So what if I have the antiderivative of sine to the 101st x, 101st power x dx? Well, I can still want to rewrite that. I can still pull a sine to the 50th, sine squared x to the 50th power. That's sine to the 100th, right? Times sine x dx. And then what I can do is I could say, well, this is equivalent by my trig identity to 1 minus cosine squared, cosine squared x to the 50th power times sine x dx, right? So the question would be, is there a different thing we can think about? Sure, I could let u equal 1 minus cosine squared x and just use substitution here. And if I do that, what's du equal? Well, du equals derivative of constant 0, so this would be minus 2 cosine to the first times derivative of what's inside by the chain rule, right? Derivative of cosine is minus the sine, right? Dx. So anyway, what happens here is, of course, the minuses cancel out, and that'd be plus plus, and then I would get, I want to rewrite this in terms of u. So sine x dx is du over 2 cosine x. And so I could rewrite this a little bit different. So I could rewrite it as the antiderivative of u to the 50th power, right? So that part's easy. But then,
Amy Moreno, could you please return to the front office? Amy Marino to the front office, please. Thank you.
Okay. Anyway, I can pull that 2 out front as a half, right? But the question is, how do I rewrite cosine x in terms of u? And I can do that. I'm going to use purple here because I need everything in terms of u. So I'm running out of time here. But basically, if I solve this for cosine x, what do we get? We get cosine squared x is 1 minus u, right? So cosine x would be plus or minus, because you took the square root of 1 minus u. Of course, we can assume it's the positive one. And so really what I can do is rewrite this as, I'm going to try and remember this, what I had. Whoops. But I had u to the 50th, right? Over the square root of 1 minus u. I think there was a 1/2 out front and then du, right? And then I can use substitution again, and I could let w equal 1 minus u. And so I'm going to get a square root of w down there. And then I can say that u equals 1 minus w. dw is minus 1, right? du. So dw is minus 1 du, or minus du. So minus dw is du. So this is equivalent to minus a half times the antiderivative of 1 minus w to the 50th power all over the square root of w dw, and we could keep going that way. Of course, either way, we may have to multiply that out, which isn't real pretty. So I don't know, seemed to work really nice on the sine to the 5th of doing this process. I don't know if it's going to work out very nice here, but